Hi everyone, welcome back to Waken Rapid Manufacturing's channel. I'm Stella. Right here in front of me are a few of the most critical parts of a car headline, the reflectors. Their surface finish directly determines the brightness, zoom angle, and even the overall visual quality of the light. The one I'm holding here is a reflector of an electric bike headlamps. It is made from PC material, and this project involves producing 1,000 pieces. Making a single prototype with a perfect optical finish is relatively easy, but in a small batch production, keeping every reflector consistent in both appearance and optical performance, that's the real challenge. So today, I'm going to walk you through how we achieve a mass production level mirror finish on this reflector.
Look at the design. The center area of this reflector has several holes that are used for positioning and mounting the LED chips. Around the outer edge, there are 12 decorative lines that give the headlamp a stronger sense of depth and a refined metallic look when it's lit up.
The customer had a very high expectations for the surface quality of the reflectors. Not only did they want a flawless, uniform plating layer, but they also set a different standards for different areas of the part. The A side, which is the main visible surface, had the strictest control over brightness and surface defects. Only a few tiny imperfections were acceptable. The B side, on the other hand, focused mainly on functional and assembly surface, where minor marks were acceptable as long as they didn't affect fit or overall appearance. So during the mold design stage, we already took the plating zones into consideration. By contouring the surface roughness of the molds, the part could meet the plating requirements right after injection molding, without any additional surface treatment.
At the same time, during the early DFM review, our team at Waken also anticipated the challenges that might come up during the plating process. This reflector has multiple levels and curved surfaces, along with several small holes. That means the plating, thickness, and absorption time on those areas have to be precisely controlled. Even a slight variation could lead to uneven reflection or color inconsistency.
To make sure every detail of the parts achieved an ideal plating result, our engineering team carried out multiple rounds experiments. We test everything from base coating curve time, coating intervals, to plating current and temperature curves, verifying each parameter step by step. For everyone, we produced several samples and sent them to the customer for first article approval.
Each batch was carefully compared and tested, with detailed records on the reflectivity inside the small holes, the adhesion of the plating layer, and the color stability of the surface.
After continuous adjustment and data analysis, we finally determined the optimal plating parameters. The coating now adheres even across all areas of the part, giving it consistent brightness and stable reflection performance. In the end, the finished reflectors reached an optical-grade surface quality. After the plating process, every single reflector went through a strict quality inspection. Together with the customer, we established detailed appearance inspection standards for each specific surface zone. Our inspectors use gauges and manipulators to carefully check the clearness, plating uniformity, and overall reflector quality of each part. During batch production, all 1,000 reflectors were fully inspected for surface appearance, and every inspections record was documented, fully traceable to each batch and process parameter.
Finally, all qualified parts were labeled, packaged, and delivered to the customer after passing our complete inspection process.
If you also have the optical opponents or small batch appearance parts that need to be manufactured, feel free to reach out to us. We'll provide a flexible and efficient one-stop manufacturing solution tailored your project needs.